So we'll continue now with the final section of the this year's Gerry Hedley conference. So it'll follow the same pattern as before. So we'll have two speakers. We've got Tara and Maria, and then we have the questions afterwards. But if you think of any questions during the talks, feel free to pop it in the group chat, and then we'll ask the speakers at the end of both talks. So Tara, Tara Laubach, who is a student at Northumbria University, is going to present to us on media analysis on the works on paper of Charles Henry Sims, with special attention to and comparisons of suspected use of handmade and commercial egg tempera. So I'd like to invite Tara to begin her talk.
Hi Tara, we can't actually hear any sound right now. Are you playing a video or are you going to speak over your slides?
Hello.
Hello.
I hope everyone is doing well and had a good lunch break.
We can hear you now.
Can you hear me? Can anyone hear me?
Yeah, we can.
Sorry about this.
That's all right. Take it away in your own time.
Can you hear me?
Yep.
Okay, I'll begin now. Sorry about that. A bit of technical problems. Hello, I hope everyone is doing well and had a good lunch break. My name is Tara Laubach and I'm currently studying the conservation of fine art on paper at Northumbria University. I'm excited to introduce my current research project, Media Analysis on the Works on Paper of Charles Henry Sims, IRA, with special attention to and comparisons of suspected use of handmade and commercial egg tempera. A planning painting for And the Fairies Ran Away with Their Clothes by Charles Sims is currently shown on the screen. During the latter part of the 19th and the early part of the 20th century, the practice of painting in tempera experienced a period of revival. During this time, Romantic painters, especially in England, Germany, and also in America, looked back to the techniques which had been used during the Middle Ages for inspiration and knowledge. The resurfacing of this movement came about largely due to the translation in 1899 by Christiana Herringham and subsequent rediscovery of Cennino Cennini's book, The Craftsman's Handbook, or Il Libro dell'Arte, originally written during the 15th century. Tempera had a reputation of tried and tested durability, owing largely to its low sensitivity to moisture and temperature, and its resistance to discoloration and craquelure when compared with oils. The search in the 1920s for a nostalgic or revisited expressive language also came about largely due to the aftermath of the First World War, where everyday lives were changed irreversibly and culture inevitably followed in its wake. Charles Sims is one of a generation of artists who reflected an interesting liminal state of cultural expression that does not fit into the frameworks of either solely traditional or solely modernist styles. Sims' interest in material science and durability drew him toward the tempera revival movement, while also acting as an example of it and thus spreading its influence. As a highly renowned master of the painting school, his popularity and impact on other blossoming artists enabled the interest in tempera painting to grow and spread. It appears that Sims used possibly both handmade and commercial preparations of tempera in his artworks, yet this has to date only been scientifically analysed on his works on canvas. It is suspected that Sims mostly would have made up his own tempera in the traditional manner using egg yolk, water and pigment. However, it is also possible that he bought commercial preparations, which would have been quicker to execute sketches or paintings created outdoors. The use of tempera was traditionally related to a striving for longevity and durability. However, the additives in the commercial preparations by companies such as Dahle and Rowney, Winsor and Newton, and Reeves in England, and Richard Wurm, Franz Gundermann, Philip Fleischers, Hermann Nisch and Co., and Alphonse von Pereira in Germany have yet to have their aging characteristics tested and compared. The commercial paints were liable to contain strong preservatives or disinfectant to prevent the egg from going bad, and these disinfectants sometimes had a detrimental effect on certain colours. The acidity of the acetic acid, the vinegar, would have detrimental effects on both the paint layer and the paper support, as acid solutions will attract chalk or whiting grounds, ultramarine blue and the cadmiums. The introduction will consist of a historical context for the tempera revival period and to the works of British artist Charles Sims. Key aims of the project will be discussed, including the rationale for choosing this topic. Chapter 1 will provide a more in-depth overview of the tempera revival and how Sims influenced other artists, including his impact on the more international tempera movement, including in Germany and in America. Further information on Sims' materials will be discussed, with attention to his mixed use and approach to media, where he often employed a blend of traditional techniques with more modern and outsider stylistic tendencies. The influence of Sims' innovative character on his painting style will add to this. Chapter 2 will engage in a brief history of the different meanings of the word tempera throughout history and geographically speaking. For example, in the US and UK, the term is confined to egg emulsion, whereas elsewhere in Europe, the term can often historically refer to any paint medium that is water soluble. The different types of emulsions, which have been labelled over time as tempera, will be explored, including egg tempera, casein, that's milk protein, resin, and wax formulations. Reference will be made to the commonly used ingredients and recipes of traditional handmade tempera. Interesting additives included fig milk, camphor, honey, flaxseed syrup, and wine. Many English and German commercial preparations of tempera tube paints proliferated during the early and mid-1900s. The ingredients of some of these will be outlined. and a brief investigation given into the harmful potential of some of the additives, such as vinegar and phenol. Preservatives were used as the traditional mixture of egg yolk with pigment and water would only last for 3 or 4 days when kept cool. The image on the screen currently shows an ad in the Studio magazine from 1928 for Reeves, which mentions tempera colours. Chapter 3 will describe the observational data obtained from several photomicrographs of Sims' works on paper. This will have informed the location of subsequent FTIR, ATIR, Fourier transform infrared attenuated total reflectance analyses, and thus further GCMS, which is gas chromatography mass spectrometry. The methodology, limitations, and results of the scientific analyses will be interpreted and explored. The aims and objectives include to broaden the understanding of Sims' working techniques and materials, and thus add to the knowledge about the working habits of a prominent 20th century artist, to provide a concise record of the ingredients in selected popular commercial tempera tube paints, which may have been used by Sims on his works on paper, and to undertake scientific analysis on Sims' sketches and preparatory works on paper in order to search for the presence of tempera. The GCMS samples are shown in the current image. A Tempera Revival Conference took place in 2018 in Munich in Germany, which highlights the current relevance and uncovers progressive new discoveries and analyses in this field. Tempera painting, experiment and innovation from the Nazarene movement to abstract art consists of 17 essays, ranging from topics of microstructure to the important question of historically relevant and thus accurate interpretation of paint mediums, historical recipes, and also analytical confirmation of the presence of tempera in the works of prominent artists such as Paul Klee, Edward Steichen, Henry Ossawa Tanner, and Christiana Herringham. Charles Sims' picture-making technique and inspirations, subjective style, provides a limited account of the materials Sims used, including the mention of rough paper as a support for the distemper ground. Sims describes the advantages of the tempera medium, and he confirms that he used the traditional recipe for his handmade tempera, consisting of egg yolk, water, and pigment. There is some literary evidence in Charles Sims' own personal diaries, as described by Jane Colborne, which suggests that he used possibly both handmade and commercial tempera in his artworks. Jane Colborne's PhD, A Critical Survey of the Materials and Techniques of Charles Henry Sims, RA, with special reference to egg tempera, media, and works of art on paper, provides a brief history of Charles Sims' life and of his painting materials and styles. There is reference to the different mediums he employed, including pen, ink, and wash, charcoal, Conte crayon, watercolor, and egg tempera, including studies into the ground and priming used. The pigments used by Sims, including the reasoning behind them, are extensively discussed, as are valuable inclusions from his studio diaries. Among these, several refer to several brands of commercial tempera used by Sims to paint outdoors. Details of the ingredients of Rowney's tempera colours are also provided. The chemist and university professor Alexander Eibner's innovations in the scientific analysis of organic materials are highlighted in his article from 1927, Egg Tempera, 8 Pieces of Monograph on Painting Technique. He described the development so far of the scientific analysis of organic materials, clarifying the progress made between qualitative and quantitative results. The characteristics of egg tempera are discussed, as well as the history and the distinctions made between uses of different parts of the egg. He clarifies that artificial wax emulsion was a more durable form of tempera than egg tempera, and claims it could have been the original tempera during Egyptian times. The Munich Art Historical magazine has an article by Ernst Berger in 1908, New Paints, the Tempera Colours of the Trade, which summarizes the different categories of several commercial tube paints. He designates 5 groups of tempera, namely adhesive, gum, oil, egg oil, and casein. Commercial tempera paints which can be mixed with either water or oil are also mentioned. There is further information on the composition of both early handmade tempera and German tube paints in Reinkowski-Hevner's The Discovery of Tempera Painting in the 19th Century. An in-depth approach is provided toward describing the development of tempera painting, its history, and the reasons for its revival in Germany. The development of chemical analysis as used in conservation is outlined, including the dates which FTIR and GCMS became possible. The chapter GCMS in the characterization of protein paint binders in the book Organic Mass Spectrometry in Art and Archaeology by Colombini and Mondugno gives an overview of the types of proteinaceous substances found in artwork, including casein, parchment glue, and egg tempera. Information is provided on interfering factors which may influence the characteristics of the amino acids and thus the interpretation of the analyses, such as natural aging reactions, including denaturation of the proteins, and the interaction of proteins with metal cations within the paper. Commonly applied sampling methodologies are briefly described, as is the pre-treatment of samples and data interpretation. I will choose several of Sim's works on paper, which, once examined under the microscope and with the aid of photomicrographs, appear to show the characteristics of tempera paint, for example, bubbles in the paint layer. I aim to undertake FTIR and GCMS analysis on at least 3 of the selected works as a method of qualitative data collection. I will then interpret these results in order to determine whether tempera is present in the artworks and what type of tempera it may be, because they're not all based on protein. Some are based on carbohydrates, such as the gums. I will research 2 books which are housed at the National Library in Leipzig, Germany, from Böcklin to Kandinsky by Wiebke Neugebauer, and The Discovery of Tempera Painting in the 19th Century by Eva Reinkowski-Hevner. I will then translate relevant citations from these German books. I plan to create some tempera, gum arabic, and gouache samples, each using zinc oxide, in order to compare the working characteristics and appearances of the different media as a method of observational data collection. If possible, I will visit the Reeves Archive at Hackney Borough Council in London and the Winsor & Newton and the Roberson Archives at the Hamilton Kerr Institute in order to search for information on English commercial tempera formulations. And I will contact Nicholas Walt at Cornelissen & Sons in order to request any information from the archives there in connection with tempera or English suppliers of commercial tempera tube paints. Due to the fact that scientific analysis may only be carried out on selected works of Sim's oeuvre within the time frame and considering the availability of resources for this project, the results will only represent a limited portion of his work. Therefore, if no analytic evidence of tempera is found on the selected surfaces, this will not discount the use of tempera in other of Sim's works on paper, which will not have been tested yet. Shown on the screen now and forthcoming are several of Sim's pieces, which will be tested. The archives of the British art suppliers in question, Winsor & Newton, Reeves and Rowney, may not provide much information on the composition and ingredients of their commercial tempera formulations, and there may be copyright protection on their commercial recipes. It also may not be possible to visit the archives as they may be closed due to the pandemic. The slide now shows 2 of Sim's paintings of Lady Rock Savage on paper and card. One of the difficulties faced when undergoing organic analysis is the possibility of foreign substances or contamination products affecting the end results. Among these dangers are pigment interference, detection limits, the migration of mobile chemical markers, such as fatty acids, and the formation of degradation products. FTIR ATR could take place by directly laying the artworks recto down under the ATR probe. Therefore, non-destructive analysis was possible in order to obtain an indication of whether or not protein may be dominant in the media or perhaps part of a mixture. Proving the presence of egg tempera by more particular means, such as by identifying the presence of the associated hydrolyzed amino acids, could not be obtained by non-destructive methods. Therefore, it was concluded that some minimal sampling was also required. The locations for sampling were chosen in either an inconspicuous location or beside an area of damage, such as a tear. Actions were taken to minimize any visible or disruptive effects while also fulfilling the requirements of the sampling. It was difficult to obtain the amount of pigment needed, which was 1 milligram, as most of the selected of Sim's paint layers indicate lean tempera or thin washes of a water or oil-based medium. Using a blunt scalpel blade, a fine sable brush, sharp tweezers and an awl, the paint samples were carefully scraped away from areas in the paint which contain more pastos or impasto layers. The brush was used to transfer the resulting powder to a small glass vial, where it was kept until further steps were taken to prepare for GCMS. In conclusion, Charles Sims and his use of tempera contributed to the tempera revival movement of the late 19th and early 20th century. This included not only egg tempera, but also a number of artificially produced commercial preparations. If you think of any questions later on, or would like to read a copy of the finished research project, you can email me at the address on the screen, tarajlaubach@hotmail.com. Thank you.
Great. Thank you so much, Tara, for that fascinating talk. It was really wonderful to hear. So next up, we have Maria Carolina Peña Mariño. I hope I've said that correctly, who is going to be talking to us about the diverse uses of starch in paintings. So I'd love to invite Maria to come and give us her talk.
Well, hello and good afternoon. Before I start, I would like to thank the Courtauld Institute of Arts for this space, as well as this year organizers for making possible this virtual version of the Gerry Hedley Symposium. It is really a pleasure for me to present here today, despite being, well, on the other side of the Atlantic. Today, I will present to you the paper entitled Unnoticed, the Diverse Uses of Starch in Painting, which will be published in the next issue of the Hamilton Kerr Institute Bulletin. In this talk, I will aim to contextualize the use of starch as a painting material, demonstrate some of its most frequent applications, and point out the challenges surrounding starch identification within the painting stratigraphy, using as a case of study a pen and pair by Francesco Guardi. The analysis of these two paintings, San Giorgio Maggiore with the Giudecca and the Dogana with Santa Maria della Salute, both from the Wallace Collection, London, sheds light on the artist's practice and gives some information about the trade in art supplies in Venice during the 18th century. I will begin by explaining briefly the basics of starch and its physical properties. Then I will discuss its most common uses through history and as a painting material. And finally, I will focus on the painting's case of study. Starch is a naturally occurring carbohydrate found in the seeds, roots, and tubers of plants, and is one of the main components of the human diet. Since the beginning of agriculture, it has been isolated from common crops. Starch is a macromolecule composed mainly of two types of polysaccharides, linear helical amylose and branch amylopectin, frequently found at an average ratio of 25 to 75% respectively. As a solid, it is a tasteless and odorless white powder made of minuscule semicrystalline granules, which vary in shape and dimension according to the botanical species of origin. These granules are insoluble in cold water, but can absorb liquid and bind with other molecules by adsorption. In the presence of excess water and when subject to increasing temperatures, starch granules gradually allow water into their structure and swell irreversibly until a hydrocolloidal dispersion is formed. In this process, known as gelatinization, the granules disintegrate, producing a smooth, viscous material, which is very familiar to us. Starch paste. Widely available and with useful physical properties, starch was employed as an additive in the manufacture of many common goods, especially in the paper-making, textile, and cosmetic industries. First references to the use of starch date back to Egypt's pre-dynastic period, where it was used as a starch paste to bind together individual strips of papyrus to achieve the desired length of the scrolls. Evidence of the use of a starch size has also been identified on Chinese papers from 312 BCE. In Roman times, Pliny the Elder also mentioned it as a material for sizing papyrus. Starch base is still used today as sizing in paper manufacture. Since the Middle Ages, starch has also been used to stiffen fabric, prevent creasing, assist ironing, and repel soiling. It was commonly used for church linens, lace, and fine garments in habits and rich households. However, it is not until the mid-16th century that professional starchers and laundry starch making became an official industry when ruffs and cuffs came into fashion in Northern Europe. To temporarily tint these pieces of clothing, laundry starch was sometimes colored blue, pink, or yellow using organic dyes, as testified by these portraits here on the slide. Coloran and color starch was used in cosmetics as a main ingredient for face and hair powder, color creams, and blusher, etc. References to the use of starch in panel painting exist but are unusual. In contrast, starch is frequently found in association with paintings on canvas. Historical sources suggest the use of starch or flour paste as size and main component of the ground began around the 16th century in Italy and Spain and moved progressively to Northern Europe. Recipes of this kind are found throughout the 19th century until the beginning of the 28th century when synthetic materials started to be introduced for this purpose. The gradual transition from panel to canvas as the preferred painting support is likely to have made artists reevaluate the traditional preparatory systems, motivating the introduction of alternative materials and methods better suited to this new support. It is possible that the idea of using flour or starch for sizing and as component of the ground layers in canvas paintings derivates from their more conventional uses as glue and size for paper and a stiffener for fabric. A paste of flour or starch exhibits a gel-like consistency that allows it to conform to the surface of the canvas, covering the fibers and filling the interstices of the weave. As it dries, it creates a flexible coating that retires moisture absorbency and repels soil and oily substances to some extent. For this reason, it became the second most common material for sizing after animal glue, particularly when dealing with open weave fabrics. Flour paste was also used extensively in Southern Europe as a main ingredient for grounds. Its thickening and emulsifying properties allow it to be used in combination with other binders such as glue or oil, as well as with lead white, chalk, and pipe clay to produce semi-absorbent or absorbent layers capable of giving the canvas a smooth finish. Nevertheless, some authors, like Pacheco and Volpato, for example, warn of the disadvantage of this sort of grounds, as they are prone to decay quickly in damp conditions or crack heavily within a few years, causing the painting to flake off. In its solid state, starch is an ideal bulking material. Given its semi-crystalline microgranular morphology, translucent white color, low refractive index, size between 10 and 50 microns, and capacity to absorb liquid and swell. For this reason, it was sometimes used as a filler or pigment extender. Starch has been found as an admixture for pastiglia and as a filler in ground layers dating back to the 13th century. Granules of starch were also identified in association with lead white pigment in the second ground of the portrait of Nicolaas van Beek and Agatha Bass by Rembrandt, as well as in paintings by Luca Cranach the Elder. In addition, starch has been identified alongside high tinting pigments such as cochineal red lakes in paintings by Giovanni Antonio Pellegrini and Canaletto. It was also found in 19th century paintings by artists such as Delacroix, Monticelli, Van Gogh, Cézanne, Degas, Renoir, and Monet. Starch has also been noted in association with Prussian blue in various paintings in the collection of the National Gallery, London. When found in association with organic pigment, it is hard to say when starch is being used as an extender and when as a substrate. Due to its insolubility in cold water, its capacity to absorb liquid, and its molecular structure, starch granules can absorb other molecules, making them possible carriers for dyestuff. Early Italian sources contain recipes for making red lakes and blue pigments with starch, sometimes on its own or in combination with lime wash or quicklime. Lake pigments made with starch and chalk, however, proved to be even more fugitive than those made with potash, alum, or lye substrates, and as such were regarded as lower in quality and were referred to as fake lake. In the years following the synthesis of Prussian blue, 1704, and the publication of the recipe, many experiments were carried out using a wide array of ingredients. The presence of starch as a pigment carrier for Prussian blue, sometimes alongside alumina, has been reported in the literature. Nevertheless, some painting treatises from the mid-18th century to the 19th centuries warn artists about Prussian blue adulterated with starch granules or starch dyed with iodine. The pendant pair San Giorgio Maggiore with the Giudecca and the Dogana with Santa Maria della Salute by Francesco Guardi came to the Hamilton Kerr Institute between December 2018 and May 2019. Alongside their conservation treatment, both paintings were thoroughly examined in order to record the artist's materials and techniques. Analysis of the cross-sections of paint samples, amido-black staining, and SEM EDX performed revealed the artist used a double ground comprised of a first layer of gypsum and protein, followed by 2 consecutive applications of a mixture of red earth pigments. These were bound in oil and contained a high proportion of chalk, aluminosilicates, and traces of titanium and manganese oxides. Elemental identification of the upper paint layers using SEM EDX and XRF analysis suggests the pigment palette consisted of lead white, Prussian blue, Naples yellow, yellow ochre, red earths, vermilion, umber, Van Dyke brown, and carbon black. The presence of aluminium and chalk in samples taken from the water and sky were mainly attributed to the use of a mixed substrate for Prussian blue. In many of these samples, round-shaped particles were discovered in black scatter imaging, for which no elemental signal besides carbon was detected. Microchemical test was carried out on these round particles using Lugol's iodine reactor. The positive result of the staining was indicated by a dark blue color caused by the formation of an intermolecular charge transfer complex between starch and molecular iodine. It was especially interesting that some of these particles exhibit either a red or a blue ring on their perimeter in dark field and UV light microscopy. This might indicate the presence of a faded red lake and faded Prussian blue carried by the starch particles. Starch particles exhibiting the same characteristics were also identified microscopically and through Lugol's iodine microchemical tests in samples from other paintings by Guardi conserved in the past at the Hamilton Kerr Institute. Through the 17th century, the Venice art market flourished thanks to the affluent tourists who visit the city as part of the Grand Tour. Francesco Guardi turned to vedute paintings following the high demand for this subject and the success of Canaletto. However, his style was never as highly regarded, and the economic value of his paintings never matched that of his contemporaries. Wardy's low income and unstable financial situation might have influenced his pigment preferences. This would explain his choice of more affordable starch-containing lakes over more permanent ones made with potash alum or light as substrate. He might also have mixed his pigments with starch as an extender. References to starch granules in association with red and blue organic pigments in works of Wardy's contemporaries in Venice, such as Michel Marieschi, Canaletto, and Pellegrini, might give some insight into the available formulations of organic pigments in the city. By the mid-18th century, the specialized vendecolori, who provide materials for artists, were going out of business and were being absorbed into the more generally especieri da grosso, who also sold common goods. The demise of the specialist color sellers could have influenced the quality of pigments available and could be responsible for the adulteration of high tinting or highly opaque pigment using starch as an extender. In addition to finding starch granules within the paint layer, analysis of dependent paintings found starch in Wardy's preparatory layers. Lugal's iodine solution testing demonstrated that starch, rather than protein, was the main binder for the gypsum used in the initial ground layer in both paintings. While this result is surprising, it is worth noting that molecular iodine staining is not often carried out during technical analysis, especially if more common binders have already been identified. The presence of small amounts of protein suggests the starch paste was either mixed with a proteinaceous substance, such as animal glue, egg, or casein, as suggested in some recipes, or that whole flour was used in rather than processed starch. Starch-based isolation layers were also identified between successive ground applications using the same reactive. These could have been used as barriers to prevent the disruption of the layers underneath and reduce the drying time between applications, suggesting a hasty canvas preparation process. Wardy may have bought his canvases ready primed, and therefore the presence of starch as a binding medium for the ground may have more to do with the economic necessity to buy cheaper materials than the artist's technical preferences. By the 18th century, oil grounds had almost entirely replaced gypsum and paste-containing grounds due to their higher quality and durability. It is likely that Wardy's financial situation led him to select lower quality materials like those Volpato had warned against acquiring from shops a century earlier. As a conclusion, the availability and versatility of starch has motivated artists to use it as a material in the creation of paintings, especially those on canvas. It is an inexpensive material that can be used as size, binding medium, or coating in its paste form, and as filler, extender, or as a substrate for organic pigment in its powder form. Wardy's Venice Vedute paintings illustrate some of its most common uses and demonstrate the challenges surrounding starch identification within the painting stratigraphy. Although there are many historical sources that refer to its different uses as an artist material, the starch tend to be unnoticed when examining paintings, resulting in relatively few references in technical studies. This could be due to limited access to identification techniques or to assumptions made by researchers who disregard the possibility that starch was used as a binding medium, particularly if they have already identified other medium, such as oil or protein. Starch granules are also difficult to identify, as they have diverse morphology depending on the plant source. Moreover, they are colorless and therefore can easily be mistaken for other pigments or common extenders. In rare cases where starch is identified, its precise purpose is often hard to determine. As a substrate, the organic pigment that was carried by the starch might have faded completely, leaving the granules colorless and indistinguishable from their use as an extender. In the case of these two paintings by Wardy, a CMEDX analysis was helpful in the initial detection of starch in paint samples viewed in cross-sections by emphasizing the granule's morphology and its organic nature. Subsequent microchemical tests with Lugal solution corroborated the presence of starch and identified in the ground layers of the painting. Starch was never considered a high-quality material. Its disadvantages, both as binding medium for ground and as substrate for organic pigments, were widely known before Wardy's time, and were probably issues of which the artist was aware. It is unlikely, however, that that Wardy selected art supplies containing starch for technical or aesthetic reasons. As a cheap and widely available material, Wardy may have favored ready primed canvases and pigments made using starch for economic reasons. Starch was also found as a substrate for organic pigments in samples from other paintings by Wardy. This evidence is worth exploring further, as it could be useful for understanding the artist's practice and helpful for dating purposes. Finally, the discovery of starch granules as a substrate for organic pigments in samples from paintings by other contemporary Italian painters suggests that these pigments may have come from a common manufacturer or supplier and give some insight into the trade in artist materials in Venice during the 18th century. Thank you.
Great, thank you, Maria. I'd like to invite both Tara and Maria to turn on their cameras, and we have a few questions in the chat. So firstly, Tara, what was the function of fig milk in the early handmade temperas?
Fig milk, it accelerates the drying process, but it also acts as an emulsion and a preservative. So they added it with the function of being a preservative, but they didn't realize at the time, they didn't have the science in the late 1800s yet to know that it acted as an emulsion. So they would mix it with other emulsions such as egg, whereas it wasn't actually needed for that function.
Okay, that's interesting. And also, when was egg tempera first thought to have been used?
So the first mention is around 35 AD by Pliny the Elder, but it was also thought to have been used in Egyptian times as a wax emulsion, which was called tempera, and that was actually the most durable, the wax emulsion, and then the casein and the egg, and then the gum tempera was actually one of the least durable.
Okay, great, thank you. And for Maria, is there a sense that lakes using starch substrate were cheaper or less high quality than lakes with inorganic substrates? And does the starch substrate affect the light fastness or aging properties when compared, for example, to chalk substrate?
Well, yes, it was already known back then that the lakes made using starch were a lot more fugitive than those made with other substrates. And this has been proved through time. In the case of chalk, I think there is more similarities between it and the starch, and it's due basically to the way in which these substrates are complexing or chelating the dyes. But of course, that it's research that has also to be done to understand thoroughly the mechanism, the chemical mechanism behind this chelation process done by starch, because nobody has, or at least I couldn't find anybody who researched that already. So in that case, yes.
Great. And one final question for you, Maria. Could the starch also be used to give body to paints? For example, in textured paintwork found on the buildings in Guardi's backgrounds?
Yes, I also thought about that, but in that case, even though you can use the starch as powder to bulk up materials, that it's because we found starch as powder in the paint layers, not as in the ground, that it was made out of a paste. But the thing is that if you use it that way, it would mean that the places where we took the samples would exhibit some impastos, and we took the samples from areas in the sky and the water where there were no impastos whatsoever. But it's also something that could be explored further, and that would need a historical reconstruction. So that was something that I also wanted to do, but well, there was not much time, and well, all the pandemic prevent me for keeping the research going.
Yeah, hopefully that's something you can maybe explore, perhaps.
Yeah, absolutely.
Yeah, once you're back. All right, I think that's everything for questions for this section. So I'd just like to take this moment now to thank the Research Forum, especially Fern and Acacia, for all their help organising this event, because without them, this wouldn't have been possible. I'd also like to thank all the attendees. I hope that you've enjoyed today just as much as we have. And even though it's been an online format, I think it's been just as fascinating to listen to everyone's research, and it's so sort of varied and wide-ranging. It's been great. And finally, on behalf of myself and my classmates, I'd like to thank all the speakers for their talks and giving their time today. And despite the coronavirus pandemic, we've still managed to get 10 speakers from all 3 courses, so it's been absolutely wonderful. So yeah, just a big thank you to everyone. Oh, and also the talks will be recorded and placed on YouTube, probably by tomorrow, but I think everyone will be sent a link, and also keep an eye out on all the socials, because I think the Research Forum will post it on there once they're uploaded. So thank you, and hopefully see you next year in person.